to the Master Olusegun maths class. In this video, we are going to teach you integration by part, one of the questions, and having a questions of arctan, integrate arctan x and xds upper and lower limit. The first thing you must put in place, let's try to relate uv. Let's make u is equal to arctan x and v is equal to x, and there is a specific formula for integration by part, which says that integral uv dx is equal to u integral v dx minus integral, you open a bracket, du dx integral v dx all total dx. So this is just a general formula for integration by parts. And let's try to differentiate u. We have du dx is equal to 1 over 1 plus s square, and we have integral v dx will give you integral x dx, which is equal to s squared over 2. So now we now need to input the formulas and input the variable into the formula. So we have integral uv dx is equal to, what is the value of u, as we have said earlier, is arctan x, which says arctan x. Integral v ds give us dot s squared over 2 minus integral, you open a bracket, du dx give us 1 over 1 plus s square. Now dot integral v ds will give us s squared over 2 all total dx. So we continue to have, let's try to bring this s squared over 2 at the back, over 2, that is arctan x minus integral. Let's try to bring this half also into the, we have s squared over 1 plus s squared. You close the bracket and the x. So we continue from here. So we see into the right, s squared over 2 arctan x minus, let's try to bring this half outside and now have this. So we have s squared to divide 1 plus s. There is a little thing we need to do here. Let's assume that we have 1 plus s squared, you open and close the bracket, minus 1. You know, it's still the same thing as s squared to divide 1 plus s squared all total dx. So therefore we have s squared over 2 arctan 1 x minus half onto integral. We have, you open a bracket for this, so we have 1 plus s squared minus 1 over 1 plus x squared. So what we need to do here at dx, what we need to do here is we make this denominator to divide each one by 1 by 1. You know, we have a bracket for this. So let's try to do this. We have s squared over 2 onto arctan x minus 1 over 2 onto integral. So we open a bracket for this, 1 plus s squared over 1 plus s squared minus 1 over 1 plus s squared. So all total dx onto half. So we continue to have s squared over 2 arctan x minus 1 over 2. Now integral. So this we cancel this. We have 1 minus 1 over 1 plus s squared. So dx. So let's try to expand the bracket with the integration, which we have s squared over 2 to multiply arctan x minus. Let's try to expand 1 over 2 integral dx minus times minus plus 1 over 2 integral 1 over 1 plus s squared dx. So we have s squared over 2 arctan minus x. So by the time we integrate the x, we have minus x over 2 plus, that's what we have, minus x over 2 plus half of this. So the integral 1 over x plus s squared will surely give us arctan x. So, but the question given to us is to integrate the upper, which is 1, the lower, which is 0, arctan x onto x dx. So we need to apply the upper and lower limits to it, which we have in the upper limit, which everything will give us. The fancy we must put in place. So it is equal to, you open a big bracket to have s squared over 2 arctan x now minus x over 2 now plus half onto arctan x. You close the bracket, we have 1, 0. So in the process for this, we apply the 1 first. We have a 1 squared over 2 arctan 1 minus 1 over 2 plus half to multiply arctan 1. So when you apply 0 to tan theta, it will surely give you 0. So from that angle, so we now we are not using degree, we are using radian. So we have a 1 over 2 to multiply. So arctan 1 will give you 45 degree, as we know already. 45 degree, and it is pi over 4. So we have a pi over 4 minus 1 over 2 plus 1 over 2 to multiply the pi over 4. So in overall, we have pi over 8 minus 1 over 2 plus pi over 8. So let's try to add it together to have pi over 8 plus pi over 8 minus 1 over 2, which is equal to, when we find the XCM, we have 8, we have pi plus pi minus 1 over 2, so which will give us 2 pi over 8 minus 1 over 2. So this we cancel, this give us 4. So the final answer will give pi over 4 minus 1 over 2. So telling you that the integral upper and lower limit of arctan x dx will surely give you the pi over 4. So try to follow this page for more topics related like this, and like and share this video. So thanks for watching.